Okay, so this stuff is on page 8 in the worksheet package. It looks a little bit different because I typed it out instead of the scanned document I used here. Right, so it's a little bit neater, but obviously there's less space because you weren't really meant to put it in there. Now, I know a few of you are saying I'd really like to do this on my computer or tablet or whatever, and that's fine. But know that it's a pain in the neck. Like, you're going to get sore hands from all the subscript and superscript and whatever to make all the little numbers. Okay, it is kind of a pain to do these on the computer, but if you want to, go right ahead. My idea was that you would just kind of write them out pen and paper, kind of do it that way, but it's totally up to you. I just know that by the time I got done typing this out, like reaching for the superscript shortcut was starting to get to me. Okay, so reminder here of what we're doing for each one of these. Okay, so for each one of these first ones, okay, it's kind of like what we did on Friday. So you're going to balance the reaction. Okay, we're going to write the equation out in words, and it doesn't need to be any more complicated than what I've written here. Okay, you don't have to make it a sentence or anything. And then write the type of reaction: single replacement, double replacement, etc. Okay, so first one's kind of already done here, but I'll walk you through the second one just to clarify. All right, so first off, we want to balance the equation, and with everything except combustion reactions, I start with what's present in the largest number. That would be chlorine. Okay, there are 2 over here, so I would need a 2 over here. That gives me 2 sodiums, so I go back here, and now my equation is balanced. Okay, the other thing is we got to write it out in words, so this would be sodium plus chlorine gives sodium chloride. Okay, nothing too difficult there. Right, and then we have to name the reaction type, synthesis. Okay, you guys shouldn't have too much trouble with that. There are going to be a couple that are going to test you a little bit with the balancing, not so much with the naming, but okay, there'll be a few that'll test you with the balancing. So know when you get to those, it's not, don't like be discouraged. I put a few tough ones in there, okay, just to make you work at it a little bit. If they were all super easy, you won't learn anything. Okay, so there are going to be a few that test you with the balancing. Okay, don't worry too much about those. Just make sure you get them done. Now, there's the ones that are like this, where you're writing them out in words, and then there's some that are given to you in words, and I'm going to expect them to be written out in formula form, balanced, okay, and reaction type identified. All right, so there's a few of each. Okay, guys, plan for today is this is something we have to practice. All right, near the end of class today, I'll pass out the Chromebooks and we'll go over the pre-lab activities for the reaction lab we're doing tomorrow. Okay, so that's the plan for today. If you need help on something, please ask. Okay, and I'll come over and help you out. Okay, but today is supposed to be kind of a coached practice kind of day, right? So make sure you take advantage of that. The thing that makes the balance tricky on number 8 is that oxygen is in all 3 places. Okay, it's in both things on the reactant side. It's in the product on the other side. Okay, so we got to look at, all right, how do I make this balance? Well, honestly, I start with oxygen in this case. I mean, there's only 2 things in this reaction, sulfur and oxygen is going to be a problem. So on this side here, on the reactant side, there are 4. On this side, there are only 3. What's the lowest common multiple? 12. Okay, so I'm going to go with 12. I might have to reduce after, but I'm going to start with that. Okay, so I'm going to put a 4 here to get my 12 oxygens, and then I'm going to go back over here and make sure my sulfur works by putting a 4 there. Okay, that's going to give me 8. So I put a 2 here, that gives me 12. But what can I do with the 3 numbers I just wrote? I can reduce it down. Yeah, I can divide them all by 2. Okay, and end up with 2, 1, 2, and this thing balances. Okay, that happens. Sometimes you just go through and you kind of have to go backwards a little bit. Question? Oh yeah, I sometimes out of habit do. You don't have to write a 1, no. Okay, now guys, for the naming also, there's sometimes questions on the naming of this. This is a molecular compound here, sulfur dioxide. Okay, oxygen, sulfur trioxide. These aren't polyatomic ions because they're not in a compound with something else. Okay, they would only be polyatomic ions, sorry, if they were in a compound with something else. Now, here's another trick on this one. Number 8 is just all trick. Okay, what kind of reaction is this? It's a synthesis reaction. It's not a true definition synthesis reaction because this is a compound, but it's two things combining to form one thing. And that's the general pattern for a synthesis reaction. Okay. Any other ones giving us trouble? Okay. 7. Okay, so with number 7, okay, we got an element reacting with a compound to produce a compound with a new element. What kind of reaction is that? Single replacement. Okay, and then so we got copper plus sodium chloride gives us copper 2 chloride plus sodium. And then the only balancing that needs to happen is here and here. Okay. Remember, guys, I did post the key for this on Friday. Okay, so it's in Google Classroom. If you go back to the stream for Friday, I did post the key for this. So if you want to check them as you go, I would say check each one. Don't do like 4. Check each one and see how you're doing on those on the key.